today's tutorial, we'll walk through creating a scene with a grid of flower petal shapes that open and close around little gems. We'll be using RayTK version 0.36, so make sure you're using at least that version. Check the video description for a download link. Start by dropping the toolkit talks into your project. I like to do that at the root outside of the main project comp, but you can put it wherever you like. In the Touch Designer 2023 builds, you may see some errors on the toolkit related to widgets inside the inspector tool, but other than that, things should generally work. We'll start by setting up the renderer. Open the palette with the Alt-R shortcut and create a RayMarch Render 3D. And then add a null top connected to the output so you can see the rendered image. Select the renderer and open RayTK's Editor Tools menu with Alt-Shift-R. And then under Add Camera, we're going to choose Look at Camera. On the camera, let's increase the FOV angle to around 70. And we can keep the default position of 0.05. Next, we'll define the SDF for the flower shape that we're going to be tiling. Open the palette again with Alt-R, and we're going to create a cut sphere SDF, and then connect that to the first input on the renderer. Then change the rotation so that you can see the flat side there. So this SDF has two modes. The one that we're using here is a sphere with a portion of it cut off. Change the shape to hollow, and because of how the SDF is implemented, you're going to need to adjust the rotation since it faces a different direction by default. So let's bring that up to around 90. Now we'll use mirroring to slice up and reflect part of that shape to create our petals. Create a mirror octant, and we're going to insert that after the cut sphere. Decrease the size, both parts of it, down to 0. And then for the offset, let's add just a little bit to like maybe 0.008 or so. And that gives it just a little bit of separation there so it's not a perfectly round circle. Next, we'll add some rotation to open and close the flower. While there is a rotate parameter on the cut sphere SDF we used just a minute ago, we're going to keep that as it is, since that represents kind of a good base state where the petals are at the halfway point between open and closed. So instead, let's create a rotate operator and insert that between the SDF and the mirror octant. So now, whatever rotation that we apply with this operator is starting from that 90-degree rotation as its kind of base point. So adjust the X part of the rotation here a little bit to around 60 or so. Later on, we're going to drive this with a field, but for now, let's just leave it at around 60. And for the Y-axis, maybe 10 or so. Next, we'll tile this shape on the X and Y axes. So create a modulo 2D, and we're going to insert that after the mirror octant. And for this operator, we can just use the defaults that it's already at. So now that we have a grid of the flower shapes, it's time to use that grid as the basis for a pattern that opens and closes the petals. We'll do that by attaching a field to the second input on the rotate operator using a wave based on the cell coordinates from this grid, modulo 2D. So select the modulo 2D, open the Editor Tools menu with Alt-Shift-R, and under Reference Variable, I'm going to choose Cell Coordinate. So that will create this variable reference operator. So let's move that over here near the SDF. So next, let's create a wave field, and we're going to connect the variable reference to its first input, the coordinate field input. Now we need to take the single number that this wave field produces and convert it to a vector with an amount of rotation for each axis. If we try to connect the wave field directly to the second input on the rotate, with the way things are currently set up, we're going to get an error there saying that it doesn't support an input that produces float or a single number. So instead, select the wave field, open the Editor Tools with Alt-Shift-R, and then choose Rescale as Vector. So that will copy that single number to all 4 parts of the vector and then apply different amounts of scaling to each of them. So now let's connect that to the second input on the rotate. And now we don't get any error. Since we are using a sine wave on the wave field, that's going to be producing values that go from -1 to +1. So on the rescale field, let's change all 4 parts of the input low to -1. So now the output low is going to be the kind of low minimum end of the rotation, and then the high is going to be the maximum end. So let's increase the X part of the output high to maybe 40 or so. We aren't seeing anything like a pattern here. They're all just showing the same value. So why is that happening? So we're using a sine wave with a period of 1, and the coordinates that the variable reference here has are whole numbers. So every cell is effectively at the start of the wave, so they all end up with the same amount of rotation. So on the wave field, let's increase the period up to around 4. So now we can see a pattern of opening and closing spread out across the columns. You can then try changing the phase to shift that pattern across. Rather than do it along columns though, or along the x-axis, let's have it radiate out from the center. So to do that, on the wave field, we can just change the axis here to distance from origin. So now if we change the phase here, you can see how it's kind of coming in or out from that center position. Later on, we'll add some animation to the phase there to get that pattern moving. On the rescale field though, let's try making some adjustments to the other parts of the rotation. So maybe dropping some of the y-axis or something. So you get kind of an interesting range of motion there. And depending on how much you apply, you may end up getting some areas where you can kind of see all the way through. If you like that, just keep it. If not, just adjust the rotation until it gets to a spot where it isn't doing that as much. All right, so I'm going with a value of, let's see, -21 and 3. And then for the high, we're doing 40 and 9. The z-axis in this case doesn't really do anything. That's because the original shape that we're starting with is totally symmetrical around that z-axis. So you're basically rotating a circle, and it's always just going to be a circle. Now that we have the motion set up, let's move on to the color. Let's create an assigned color, and we're going to insert that after the mirror octant. So we're going to do a similar approach to what we did with the rotation, where we're going to use a wave based on those cell coordinates. So let's create another wave field and connect it up to that variable reference. You could also create a copy of that variable reference if you want, but it's basically the same thing as using the same one. And that's something that's specific to variable reference and not to operators in general. Similar to what we did with the first wave field, let's increase the period up to maybe 3. Now we could connect the wave field directly to the second input on the assigned color, and that's going to produce kind of grayscale values ranging from black to white, or we can use another operator to map that to a range of colors. So I'm going to create a color ramp field, and then we're going to connect the wave to its coordinate input. And then we can connect the color ramp to the assigned color. Now again, the sine wave is producing values from -1 to 1. So on the color ramp field, we're going to adjust the coordinate range to -1 to 1. So then let's pick 2 different colors and pick whatever color you want. I'm going to go with maybe like a blue and maybe purple. So this now gives us colors in vertical stripes. If you change the phase on the wave, those stripes are going to move across. Now we could also change it to use rows by changing the axis here to Y. Or you could use distance from origin like we did for the rotation there, but I'm just going to keep it on the x-axis. Note that if you try to use transform operators to change this color pattern, it isn't going to do what you might expect, since that pattern is based off of the cell coordinates and not regular spatial position. The reason for that and how to work around it gets a little bit complicated, so I'm going to cover that in an upcoming video instead. Next, let's add the little gem shapes inside each flower. So for this, we're going to use an octahedron. So create an octahedron. And then let's select the assigned color and the octahedron here, and open the editor tools with Alt-Shift-R, and then under Combine SDFs, choose Simple Union. And then let's connect that combine up to the modulo 2D. So that works, but the shapes are way too big and they are gray, which is not great. So to fix the size, let's go to the octahedron and then drop the radius down to something small like 0.15 or so. And then to adjust the color, let's create an assigned color here. And we're going to insert that between the octahedron and the combine. And I'm actually going to swap these inputs around so that the flower petals are the first input and the octahedrons are the second. And the reason that I'm doing that is so that on the combine here, we can just toggle this parameter to make them appear or disappear. And depending on how you had your network laid out, the editor tools might have attached those in a different order. So just make sure to have the flower shape going into the first one. Next, we'll set up the material. If you want, you could use separate materials for the flowers and the gems, but I'm going to keep things pretty simple and just apply one material to everything. If you've watched many of the other RayTK scene tutorials, this should be pretty familiar to you. Let's create a modular mat, and we're going to insert it between modular 2D and the renderer. And it's going to go dark until we add shading elements. So let's select the modular mat, open the editor tools with Alt-Shift-R, and then under Add Diffuse, we're going to choose Orin Iron. Or you can choose a different one if you prefer. Then select the modular mat again, open the editor tools with Alt-Shift-R, and then under Add Specular, I'm going to go with GGX. And this is a pretty common combination that I tend to use for most things. But feel free to try out some of the other modes if you want. Just note that there may be some bugs in Fong and some of the other ones like that. So now that we have both the kind of base lighting and the specular highlights, let's adjust the roughness setting for each to kind of get the look that we want. So I'm going to keep the roughness on the diffuse, I'd say all the way up at 1. And then on the specular, I'm going to bump it up just a little bit to maybe 0.7 so we get a little bit of a kind of tight, shiny look, but also kind of a matte surface. And while we're here, let's also add our own light source instead of using the default one that's built into the renderer. So select the renderer and open the editor tools with Alt-Shift-R, and then under Add Light, choose Point Light. And then let's bring the position of it a little bit out on the Z-axis. So just increase that to maybe 14 or so, and then adjust the X and the Y so you get some kind of more interesting shadings. I'm going to go with like 8, 8, 14 or so. Now on the diffuse and specular, let's adjust the albedo and Fresnel settings to get things a little bit brighter. So going up to around 0.9 on albedo for diffuse, and then specular, we're going to bump that up a little bit to around 0.7. And maybe bump the diffuse up a little bit more, all the way up to 1. Last, we're going to add some animation. So we're going to animate 3 elements of the scene: the opening and closing wave, the color wave, and then also the grid to kind of move the whole thing, either up and down or left and right. So we'll start with that first wave. So with that wave selected, and only that wave selected, open the editor tools with Alt-Shift-R, and then under Animate with Speed, I'm going to choose Phase. And I'm just going to move that. And then on the speed generator, I'm going to drop the speed down to something around 0.1, 0.2. Then we're going to do the same thing for the other wave. So select it, open the tools menu with Alt-Shift-R, and then under Animate with Speed, we're going to choose Phase. Just move that over, and then on the speed generator, drop the speed down again to something like 0.15 or so. So next, we're going to shift the whole grid. So there is a pretty simple way to do that. So let's go to the modular 2D. We have this shift parameter, and when we change that, it moves the whole grid on either of its axes. But there is kind of a catch here. So to make it a little bit easier to see why, let's go over to our camera, and we're just going to move that out on the Z to around 10, so we get a wider view. All right, so notice how the pattern for the opening and closing is coming with kind of concentric rings around that center cell. Now, if we shift the whole grid all the way up, it's still centered around that one down there. So we're now getting these kind of arcs going like that. And if we keep going, it's going to get larger and larger until at some point we're basically just dealing with kind of horizontal stripes moving upwards. So instead, let's set that back to 0. So instead of moving this modulo 2D, we can add another one after it and move that instead. So let's create another modulo 2D, and we're going to insert that right after the first one. And on this one, increase the size up to maybe 6 or so. And as long as those are a whole number, you're not going to have any parts of the cells being cut off partway through. So this is basically repeating every 6 rows of that first grid. So now if we shift this one on the y-axis, it will kind of give us another area where the circles are centered on another point. We keep going, hit another one, and so on. So we can just keep going forever in any direction, and we're always going to be kind of coming over those center points. And that's true on both that axis and the other one. So we can do that too. So now it's kind of centered around that one and so on. So with that modulo 2D selected, open the editor tools with Alt-Shift-R. And then under Animate with Speed, we're going to do Shift. And you could do just one part of it if you only want to move in one direction. But let's do both parts and just do the top level one here. So that allows us to specify speed to move on both axes. And if we want to only do one, we can just set the speed for that part to 0. And then if you want to recenter things, just hit the reset. So now we can use the speed multiplier to kind of adjust the overall speed. And if you want to do, a little bit of horizontal and some vertical, you can kind of adjust those to whatever ratio you like. But I'm just going to go with only the kind of vertical axis. So now let's go over to our camera and just going to pull that in a little bit. So for the z-axis, pull it in a little bit to maybe 7 or so, just so that we can actually kind of see what's going on within the cells. And that's it for this scene. So to recap, we are starting with a hollow sphere that's been cut off, and then we are rotating it and applying this mirroring to create those kind of petal shapes. And then all of that is being tiled on a grid. And we're then using the position on that grid to drive a wave that is controlling the amount of rotation to kind of open and close the shapes. And then we're doing a similar thing for color, using that wave based on the cell coordinates, mapped to a range of colors, and then assigned to the surface. Then after that, we are adding in these little octahedron gems, and then we are doing this little trick with the tiling so that we can kind of repeat that ring pattern for the opening and closing. Then we are adding a modular material with diffuse and specular shading elements, and then we're rendering it up. So there are a lot of things that you could do with this scene from here. So we didn't really do anything to vary the gem shapes. So you could do that potentially with something similar with a pattern that's based on the cell coordinates. You could even have it kind of be the inverse of the opening and closing, so it gets smaller when it opens or something like that. And you could also do something like that for the color for those, or apply kind of a general transform over the whole thing, like having waves that kind of ripple everything along the z-axis forward and back. Or instead of the mirror octant, you could use modulo polar, so you could have more than 4 petals and so on. So I look forward to seeing what you all do with this. And if you post on social media, use the RayTK hashtag. And at least on Instagram, tag me as well if you want to make sure that I can see stuff if you want to show it off. If you want to support RayTK development, check out my Patreon. You'll get early access to tutorials, exclusive scene downloads, and more. Thanks for watching, and as always, make sure to like and subscribe.